Hi everyone, welcome to our today's webinar, a second part in the series of 3. Today I will tell you all about walls and slabs, particularly about solid walls and sandwich panels in impact, as well as solid slabs, as you can see in that preview window here that we have available. We will continue on the model from the last webinar from a month ago, where we focused on beams, columns, and hull cores. So, moving on, today's agenda will be consisting of modeling solid walls, sandwich walls, and slab elements, as mentioned before. We will also create wall joints, so selecting end caps and particular cast-in materials for elements. We will also use cast-in material templates. So this will allow you to place multiple cast-in materials at particular end plates if you don't want to click through joints on every element junction. I will also demonstrate how to create reinforcement groups in elements. After that, we will save elements to the impact database. We'll generate shop drawings, because to generate the shop drawings we need to first save elements into the database. And we will preview the elements in an impact project manager. This might come before, or rather just after we save the elements to the database. So, without further ado, here's our project. That's the model. That's the model that we had from before. And with that, I'll just open up one of the drawings available for us, the floor plan. I already have that open. I've opened that in the background so we didn't have to wait too much. And with that, let us go ahead and start actually working with sandwich panels. We'll create a small building on the side of that big storage facility or factory of sorts. So under the tab walls, basically what we'll do is we'll click on the create or draw wall icon, and we'll select what type of wall we want to create. For me, I want to create sandwich panels. And like that, I immediately can start placing sandwich panels. Okay, so first I would like to place sandwich panels from this corner of the column to the other side, and I'll do it like so. I'll snap to one point. Important thing of note is first the direction we draw in. And as you may see, if I go to the right, there's an arrow on the top of the wall as we look at it, and opposite to the unmarked text that you can see, right? This basically marks where the internal panel is for our sandwich panels, right? If I go counterclockwise, my internal panel is basically down on the screen that we have right now, okay? If I go the other way, so say clockwise around placing the walls, then the internal panel is on the outside. So basically this little arrow indicates where the inside of our building is for sandwich panels, right? I don't have to change anything since I'm going this direction, but what I want to change is the alignment of the wall. So I will just press LE on the keyboard as per tooltips on the bottom, and I'm good. I place the wall on the left side of the placement line. So I'm just going to click. You can immediately see, I'll press space for you. You can immediately see that the wall is marked red. That means it's too big. We have settings in impact. They mention that if an element is too long or too heavy, it will give you such a warning, right? So the warning is red, so something's wrong. I'll continue on placing some other elements, and let's just press space, select sandwich panel. One thing of note, I didn't show that with the first wall, but if I press P, I can change properties of the wall, the sandwich panel. So I just have the sandwich panel of thickness 34 in my project. That's perfectly sufficient. for us and for the demonstration. I could import more from our global database, but I don't need them. So we don't have to do that. There's a couple of levels for the standard that you have. There's the overall, say, common standard. So that's company specific, company wide. There's also local, that's one level below that. And the most compact standard is the project standard. Maybe you don't, maybe your factory creates sandwich panels 30, 35, 36, 37, like every centimeter thickness, right? But for one project, you might just need 34s, or as in this case, or 40s, or just those two, and you can import those two. So it will not muddle your selection while placing those elements. For me, I'm just leaving it as is, as sandwich panels thickness 34. I'm going to cancel out of it. We can also automatically select the end cap. So if I wanted to have a specific end to particular side, either left or right of my elements, or top and bottom of my elements, I can specify that here. For now, I will select none, because the end caps I will be automatically updating while I'm doing connections between the walls, and or splitting the walls from them being too long to smaller segments. Okay. I can also specify lifts and bracings. So bracings on the face of the internal panel, those are also visible here. They're automatically placed, and they're placed by definition. So in the definition of this wall, I have a specific set of rules that define what type of casting material is for those bracings, what's the placement method. So in this case, it's placing by elevation and part of height, right? So that's basically proportion of the for our height of for our bracing elements, and where to place it. Well, do we include center of gravity for that? And same thing for the lifts, right? We can specify the type of lift. The lift definition is either by definition, so defined by the type of the wall that it is, or we can specify that manually, which unlocks all the settings. So if we don't want to think about that consciously, and we just use one type of a lift for particular types of elements, then by definition is perfectly fine. But maybe for some specific elements, there are some project constraints that you have to abide by, then you would go and do that by user, right? And that's for the top edge and other edges if there are any applicable. There's also possibility to add some specific casting materials and recipes for that, but we won't be focusing on this particular functionality today. And the last tab, model tab, is the placement of the walls. In my case, I'm placing them on the first floor, which is 3 meters high, and I'm placing the walls on the 0 elevation. If I wanted to create like a second floor of our walls, I would change that to floor number 2 and change the base elevation of our walls as well. Because this is assignment and this is the elevation of the elements. All right, so let's go back to general. What's more, there's reinforcement templates, which I will talk about briefly later during the webinar. And we can also specify how the panel is placed during production. So inner panel down, and yeah, that's it. Also a override for height for our walls. I'm going to accept that. One thing of note, my internal panel now is on the outside of the building, which I don't want. So what I do is I rotate that by inputting RO and pressing space. My text is now upside down, doesn't matter, I will flip it later. But our internal panel is now on the inside as I want it. What I also want is I want to center the wall on the axis. And like that, our wall is placed. I'm gonna undo because this wall is too big for my taste. That's gonna be too much clicking for us if I place too many walls, so I'll just skip that. So I undid that, and I'm going one by one by clicking on the elements. Right, so those are our sandwich panels on the outside of the building. They're too big, they're all in red. Right, One thing that I'll do, which will be slightly easier for us, if it bothers you in any way, you can edit this wall and just say flip, which will basically turn the text around for you to change the orientation, so everything is nice and clean on the drawing. Right, so let's continue, and with that what I'll do now is I'll split those walls. There's a split vertical command and split horizontal. So we are working in a plan view now, so I will split walls vertically. I will slice them right from the top view. But if I worked in an elevation view, then I could create like one massive tall wall throughout the whole building and split it horizontally. So let's do that. I'm going to select this panel and this panel. This way I can divide them immediately, both at the same time. I'll specify a gap of 10 millimeters, and I will also specify an end cap. I could select none, which then would just cut the wall straight, but I want to create an end cap for us like this. Okay, so let's do that. And I'm just going to click here and accept that. You can see both the end cap has been applied and the walls, both on the top and bottom of the screen, have been divided. So let's do the same thing here and here. And the gap is again going to be 10 mil, and I'm going to use the same end caps. And like that, I'm just going to click on that midpoint line, and our axes are done. Okay, so that's one thing done. What I will now do as well is I will actually create internal walls as solid panels. So this is our second type of wall. Right. And after that, I'll start connecting all the elements and showing you how it's done. Right. So first things first. First, let's model the geometry. This time it's going to be just a wall. I'm going to first start our wall from here, right? And end it here on the middle. As you can see, the wall is in red. It's too big. Right. Let's create another wall here. I'm going to do that here. On the axis, doesn't matter. It really doesn't matter that I'm not perfectly aligned. We'll fix that later, right? So that's going to be super easy for us. One thing of note, I'm just going to create auxiliary lines for me, very quick, just so it's easy. Same thing here, and perpendicular like that. Why? That's because I just want to divide those walls exactly in the middle of the span here for my convenience. But other than that, that's basically there's basically no other particular reason for me to do that. Right. So let's do that. Let's split up those walls. So I'm going to select this big wall now. Gap 10 mil, right? And I'll also specify an end cap. For those, I'll just use this type of end cap. That's a 20 mil thick wall panel. I'm just gonna do that here, and I'm gonna do that here, and accept that. Right, perfect. For this wall, I'll go more or less around the midpoint of this wall. Should be good enough for us. Gap 10 mil, same type of and enter, and like that. Now we have our walls placed. Right. I'll soon go over the connecting of those elements, but let's first click on one of those walls as an edit and select see the properties. So those are our solid panels, and as you can see, very similar window as it was for the sandwich panels. You've got reinforcement template, just the production and cast type, what type of cast type that is. Also the dimensions of or an already placed wall. We can specify end caps here. You immediately see that one has been selected for the left side, basically for this element, because it was automatically created for as between our elements. And lifts, bracings, very similar, basically all the same options as you can have. Again, types, I only have like a 20 centimeter thick internal wall, solid panel, but you can create multiples. We do have additional one in our standard, but you can of course create new ones, copy this one, multiple different thicknesses, and whatever it is that you require in the standard for those particular elements. All right, so one thing, I'm just gonna open up my cheat sheet on the side just so I don't get too sidetracked, because I like talking a lot. Right, let's exit that. Okay, so that's more or less okay. Now, first I'll show you the cast-in templates for our walls, and for that I'll just split one wall additionally in one place. Maybe this one. Let's do that. All right, I split this one 10 in the middle. That's going to be this one. Let's go. Let's put that more or less in the middle. Doesn't matter too much. The exact dimension. For the sake of demonstration, I'm just going to do that. So there's two ways you can actually connect the elements. One is the cast-in material templates. That's apply template here. Let's see what kind of templates I have. I have none, so I'll import some. Not for those. Yeah, no, okay. Those are, okay, that should be good. Okay, let's apply that. Nope, I forgot. I have to actually import them like that. Okay, so I'm importing all of those that we can have. And what I'm interested in is this one. And what the casting templates do basically is they look at the end cap that is available in the that is actually used as a connecting end cap for the element, and then applies a casting material that at a specific location, as is the case here. I can edit that, like move the casting material here, for example. As you can see, I'm moving the casting material in this particular wall. Let's go back to 60 as it was before, and let's accept that. And yeah, let's go back to that. And it looks for this casting material, which I now just realized that's a wrong end cap for me to edit. Yeah, that might be problematic for this particular one. So let me go ahead and do something else for this one. Yeah, I have wrong templates defined for our sandwich panels. So since I don't want to waste too much time on configuring that during the demo, I'll do that very simply for this wall. It will be easier to demonstrate that. Right, and again, 10 gap, and let's make it this one. Yeah, like that. Okay, so I'll quickly demonstrate how that works, and yeah, go back. So custom material templates, again, quick explanation. What type of wall I have here is for my 20 size wall. I will look for this particular end cap, which I just now applied for as I split this wall, right? I'll just open that and edit, and I will apply this particular casting material at this end cap, at this location, which is that green cross at this location. I can of course move that, say 50, and moves that inwards. 38 is sufficient, so it looks very nice. And of course, I can rotate that, move that further out. I can also change the angle at 45 degrees if we have some kind of connection like this. Well, let's leave it as at 90. And of course, the type of casting material, it can differ. We can change that to something else. I think we also have like a smaller loop. Yeah, we have a smaller loop for different types of connections. So, of course, casting materials can be added by yourself or by us. Not an issue, right? So I'll just accept that. And as you can see, we have different end caps because those templates we can define multiple different end caps available, and we can define what happens if this particular template detects any of those end caps. So let's have a look at the other one here. So that's this type of connection. And then what it does, it automatically places a casting material like this in this type of connection, okay? Like automatically. So let's accept that. And there's also different placing options. So basically for the placing options that you see here, let's go left. So the casting material that we see here, that it will be applied here, we can specify placing on the left and on the right of the wall. So both sides of the wall we can specify, and we can specify how those casting materials are placed. So that's basically the distance from the bottom, distance from the top, and the spacing that should be more or less conformed with. And there's different schemes also of placement of casting materials. So first the distance from the top, from the bottom, from the top, and number of casting materials to be divided equally at that distance from the top and from the bottom. So I'm just going to leave it at the default values. It's perfectly sufficient for us for this 3 meter wall. We might get 3, we might get 4 casting materials, right? So I'm just going to accept that. And now what I'll do is I'll apply that template. So I will select objects. So those 2 walls, since I have those two types of splits here, and I'll just accept that. Right, and specify which template to use. I want this one, and as you can see, the program automatically created the connections between those two walls. All right. The other way of doing that, would be to manually. That's casting material templates, right? So we can select multiple walls or the multiple elements in the project, and with that, the program will automatically look for any types of end caps that are defined in that template and apply the casting material that's added to that. The casting material can not only be like loops here, but it can also be, for example, type of rebar or maybe channels for connecting other elements. Basically any casting material that you can think of, and create that within the AutoCAD interface and have a 3D model of, then you can use that as a casting material template, right? So that's one way. As you can see, it was very fast. If I selected all the elements, it could connect them and join them. Yeah, that works. That checks out. However, there's also a different way. It gives you slightly more control of what's happening at the moment, like immediately, right? And that's going to be the connect wall. So this is how we create joins. So that's one of the next topics of our discussion here. I would suggest using connecting wall at more problematic places. Like for example, here we have a sandwich panel connecting to a solid panel, and so is the connection here and here, right? That's a more problematic connection, or other more difficult one to detail. So it will give you more control, and I'll just show you how that works now, right? So I'll just select those 2 elements, and what will happen is the software will try to find the best possible match for this type of end cap to end cap connection. And in this case, it immediately suggests me this particular type of connection by weld plates. I can have a look at the other suggestions that it creates, and I can see that it also creates a straight connection with wire loops. So let's use that here, and I'm going to accept that. And here now I can specify the distance, the type of setup of the casting materials on the side of my wall. So I can, for example, increase the number of casting materials, right, in this connection. Okay, and I've now applied the casting material, and I can swap the sides, or if there's a different alignment possible, it will suggest it here. There won't really be a better alignment here, so I'll just apply and update all. So this will also update the lifts and the geometry. I can also now the command is not finished. I can select another collection of this type and just press space, specify your origin of the joint, and apply. And it automatically creates that connection for me, right? And let's accept that. Basically, it adjusts also the spacing between the elements if there's need for that, right? So basically, once you define the type of connection that you create, it's like a corner or a straight connection, then you can apply that to different places in the model as long as it's the same type of element connection. Oh, sorry. Let me get a drink. So next, let's actually place this connection. So it will automatically detect that it's a corner connection between sandwich panels. I only have one type of connection like this defined, so this is the only one that it proposes. I don't have a wire loop connection defined for elements like this. So the weld plate connection is only applicable here. And to demonstrate how the preview looks like, see, I can specify which element gets extended. In this case, it would be this wall, and this would get shortened, or the other way around. So let's make the vertical wall here, vertical in view, the longer one. And let's accept that and update all. What happened now, as you can see, this element got red. It got extended, and it got extended enough that it's too big now to be lifted by our software, by the erection crew, or it exceeds our limits in software. I also select this corner, and I'll apply this particular extension, accept that, remove the auxiliary lines. No worries, we'll split those walls later, or just now, and you will see how easy it is to fix that situation. So this element is too big, fine. Let's split it, right? Let's use this particular end cap, right? And around the middle, and accept that, and do the same here. And same here. Like that. As you can see, very quick, very easy, and the model has been fixed immediately. Now, what about this? This is problematic, but still I have defined a connection like this, and let me just select that, and there's no suggestion on the type of connection. There's only one possible connection that I have defined, and that's a connection like this, and I'm going to update that. As you can see, it's done. What I do here, accept that here as well, and accept that here as well. Doesn't matter that I selected a beam, it recognizes that I'm working with the columns, and it automatically updated the connection like this. And it's done. This is basically more or less the what the placement of end caps and joining the elements together in sandwich panels. Of course, if we have a look at the 3D model, we now have a shape of a building, right? So that works. What we can do also is we can actually start placing some openings. Let's do that quickly, because it's a bit it's kind of hard to get in that building if we don't have any openings, any openings or windows, whatnot. So let me just do that. I'll just arbitrarily place a door like this, and maybe a window as well in that wall. So let's do that like that. So of course there's a command that allows us to create openings, but I need to first select the type of element, right? Like so as well. And I can have predefined types of openings available for me. There's more, of course, available. You can create more very particular openings, something that you would, of course, need or require, right? So let's undo that, because that was an unwanted click, and let's go and again create a door as well. That's gonna be this one. and let's place it somewhere here. Right. And let's leave it be for now for our elements. Yeah, one thing about reinforcement, I mentioned reinforcement templates, right? So let's actually go and talk about those. There's reinforcement templates. I have 2 available. My walls, I think, have this one applied. Let's double click on that. So what happens is for sandwich panels here in my reinforcement template tool, I can specify how I reinforce the sandwich panels. So I've got the double mesh, double rebar option. I've got double mesh, double rebar as well. It's a different kind. Single mesh and double rebar. You can see preview sketch, and you can get an idea of what happens here, right? Or just single mesh, single rebar, right? Let's go double mesh, double rebar. Let's cancel out and go back to the default one. Yeah, you can specify which panel is basically the placement where each layer of reinforcement is directed towards. Same for the outside panel, right? And you can also specify covers and offsets from bottom and top. You also have the edge reinforcement and corner reinforcement available, and opening reinforcement if there's an opening in a wall. We will be able to check that out later. As well, some wall and column beams that can be placed on the drawing later. I might show you a different way of doing things like this. In the edge reinforcement, we can specify the spacing for the end cap reinforcement if it is specified for a particular type of end cap. So let's do that now. In Impact for AutoCAD, you don't really immediately see the results of your settings for like reinforcement. That only happens once you create the drawings. But that is pretty easy to set up, and then very easy to verify that all is good once you have the elements all specified and all the settings specified. What I'll do now is I'll create sketches of end caps that I have in the model, right? So for my vertical walls, I know that I have this particular end cap. So let's draw it, right? I'll draw it in the model space somewhere outside the drawing. It really doesn't matter as long as it's in there. I can delete that or make it smaller. That's just for preview here for us, just so we know what we're doing. Then I'll create another end cap. This time this will be a sandwich panel 1, and right, that's going to be 801, and that's also the one that we used for our splits in the walls, right? So I can add that in here as well. Just draw it here like that. Oops, it's a bit crooked, so let's delete that. Let's do that again. Yep. Let me verify one thing. I'm going to edit the wall, go to properties and select the end caps and see what kind of end cap was applied. That's 804. Okay, so that's perfect. We can still do that. So this is this particular end cap. So I'll create this end cap as well for us, and for it, of course, I can place the reinforcement. Yeah, while I'm here, a quick connection. Of course, the automatic connection between elements doesn't only work with solid panels. It also works for sandwich panels. So just very quick demonstration here as well. That, oops, like that, and apply, and yes, up they go. Right. So it works as well for the solid panels. Just FYI. Okay, now so let's place that end cap that we had before as well for the sandwich panels. It's this one, slightly different as you can see in the preview. Doesn't really matter. It will be very quick for us, very similar. Okay, let's go change that quickly. Change that text to something smaller. Well, for some reason I can't. doesn't matter. Let's just move this one up. Sorry, too many clicks. Okay. All right. So now, in order to get the reinforcement in, I need to go to the reinforcement tab, and I actually need to create a bar. And that's from the bars tab. What I want to do is I want to specify the dimension of that bar. I can make that a size 10. I also want to apply offsets. Offsets will be my covers, and I'll make that to be 25 millimeters. Accept that. Or maybe let's go and make that 20. I think 20 was set for the wall reinforcement. So my offset is like that. What I'll do is I'll just go like this, like this, like this, and like this. Oops, undo. Like this, and space. The size really doesn't matter at this stage. What I need to do is I need to edit this bar. Yeah. And with that, I will manually update the size. Let's say 400 here, 400 here, which will be perfect, and 80 for this particular width of the bar. And that's it. What I also do is I'll delete the text, which we don't need. There's a bunch of settings that you can have here for representation in 2D, 3D, the steel quality, the dimension you can change here as well, the bend radius of the bar as well you can specify here, or hooks if you need to create those at the end of the bar. So you can see in the preview here, small hooks available. Let's turn those off. And I'm going to accept that, and I'm going to move that bar. Right, I'm going to move that here and move that additional 20 mil like that. Also copy that bar and copy it here as well. So slightly different end cap, as you can see. What I will also do is I will very quickly create another bar for us like that. Click, click, click. I don't need to change any settings. Settings are remembered from the last bar. So let's edit that as well very quickly. First, let's turn off the text. We don't need that. General, let's go again, 400 and 400, right? All right, and let's accept that. And I will move my bar to here. 20, 0, 0. Okay. Yeah. Now let's go back to plan and let's edit the end caps, because this is where you actually edit the reinforcement in the end caps. I'll go and open up the first end cap. So that's the 801 end cap, right? And here I have some specification of the geometry of that, the extensive of the end cap for the cast-in materials if they are placed any automatically, and the reinforcement. So let me select the objects for this particular end cap, 801, and let's select the reinforcement. And the base point, which will be this point. And we get the preview of that. And that's it. I'll just accept that and save that. I'll do the same for 804, select objects, like, oops, I did a wrong thing. It's gonna be not this one. Well, let me go back, because I've created too big a bar for this. Let's select the reinforcement, and it's gonna be this one. I chose the one for solid panel. Yeah, that works. Now this one, it will be the same bar really. Accept that, and for walls, you can see very quickly I can edit that. Of course, you would need to specify that for the other types of end caps as well if you want reinforcement like this. Since we don't really have that much time today to do that for all of those, I'll just focus on those 3, and that's it. Now, whenever we create drawings for our elements, if they contain any of those end caps, then this reinforcement will be applied. I could delete that from the model right now. It's no longer needed. It's saved in the database. That's it. It's saved. But what I would like to do right now is show you the reinforcement templates, right? Because let me go and accept those, and that's reinforcement. Let's say I want to add the end cap reinforcement, so I need to actually specify this type of spacing here. So top spacing stirrups, bottom spacing stirrups, left spacing stirrups, right spacing stirrups. So let's go maybe 50 here, 150, maybe 50, 150, 150, and let's see. So that's for the, yeah, so that's gonna be the spacing for us, or maybe 200 will be better, right? So that's the setting for our end cap reinforcement, right? To explain what happened here right now, let's go and edit the wall properties. So the walls have assigned, oh, so that's a different template, reinforcement template. So I can go back and edit this one. Basically, the reinforcement template decides on the whatever reinforcement is in the element. So let me go ahead and go back to this one, edge reinforcement. Okay, we already have some definition here for left and right side of the elements. Let's go make that tighter, 200, right? And let's save that, and that's okay. That's done, really. What I now want to do is I want to show you the panel thickening, because I want to place some slabs and I want to place them on some panel thickenings. So let's do that. Maybe in this section here. Now too many walls. So let's maybe do that here. Yeah. Okay. So what I'll do here is I want to create a panel thickening. So I'll just click on this. Sorry, not this one. Draw panel, click thickening, and I will select an element, right? So I can now specify the height and thickness of any panel thickening and the placement of that. So if I need my panel to get thicker, for example, on top to create a support for something, then I can do that here. Right, so let me draw that. Height 150 should be sufficient, thickness 100 should be perfect. So let's go and do that. So I selected the element, and what I'll do now is I'll start from this point, and as you can see, it grabbed my panel thickening in a wrong place. So let's do that again. Wrong snap, basically. Yeah. So let's snap to the edge here. Perfect. Right. That's perfect. And I'll go and I'll reach this point. Right. And yeah, that should be good. I'm going to space and accept that, update all lifts, and let's see in the 3D model how that looks like. Oops. So basically, for some reason, it's placed out on the bottom for me. So let's nothing bad happening. Let's just edit that. Select thickening. Let's edit that. And for some reason, it didn't choose the proper elevation. So I know my elevation for this should be 250, and that should be good. Let's accept that and update lifts. Yep, that's perfect. That's what I wanted. Let's maybe add panel thickening as well for this wall, just so we're consistent, right? And it's going to be the same thing. And let's accept that. Okay, and let's do that from this point. Right, and you can see the preview. Maybe working in 3D is slightly better for this. All right, let's snap that to the bottom, and like that. Like that, we have a panel thickening. Let's accept that, update lifts, and now we have panel thickenings, which is perfect, because now with panel thickenings, I'll show you later how to add reinforcement to that on the drawing, but now let's actually place some slabs for us. So slabs, very simple. We have an icon for those. It's again a bunch of settings that you can have. Definition, I just have one type of slab defined here, a 185 mil tall slab. That's it. And also 150 mil balconies. But of course you can create your new slabs, new, accept that, And you have a bunch of different settings for geometry, like width, the tolerances, the element thickness, concrete material, end caps applied as well, lifting, connection, and other elements. I'm just going to cancel out of that because I don't need to do that. And let's go OK. So for the slab, end caps you define while placing the slab, right? So we'll do that a bit later. For model, you specify basically the placement of that. So let me change the elevation of that to 3000 because that's the top of our walls. I don't want to move my slabs later. That should be sufficient to change that here, just to make sure. Of course, it snaps to whatever floor you have according to the settings and the placement, if it's by the top or something else. And again, reinforcement template for slabs, it's a different one. So you can define if it's meshes or bars, spacing of bars, etc., of course. So that's where you, so you'd go to that reinforcement template thing and change the reinforcement there for slabs. It's automatically applied while placing the elements according to the template, right? So let's accept that. And let's place those multiple slabs and let's place them by a window, right? So let me select that and I'm just going to grab that by this point and grab it go to this point. It creates one big slab for me. No, it doesn't. What I'm now asked for, as was the case for hollow cores, I'm asked to add support and possibly change an end cap, right? So I can have different types of end caps specified here or just plain straight end cap. So let's do that straight end cap here. Let's copy that to next. It's already extended by 80 mil for supporting length that I specify. I can copy that to next. This one I don't want to have a supporting edge because it's a free edge of a slab. So let's leave it like this and let's go to the next one. In here I'll change the end cap to maybe an end cap like this with a 100 millimeter support, and let's copy that to the next one as well. And let's accept that. I don't want a slope, and I can now divide that slab, or if I want I can rotate that, but of course we don't want to rotate this slab because there's no support on this end. Let's do that and accept that. I can of course move the cut edge if need be. Let's make it that free slab, and like that it's all good. If I go to the 3D model, it's placed on our thickenings for the panels, right? Yeah, so that's the gist of it, of very quick modeling. Now let me go ahead and save everything to the database. And once we do that, we'll look at the 3D model that's been updated, and after that, we'll just go ahead and start working our way in the reinforcement drawings, at least a bit. All right, so to save the elements, we go to the Wall tab, we select the Save to Database option, and let's select all slabs. Automatically, let's first save the sandwich panels, right? Let's save those. So I'm now saving those with a element mark SW1 as the first one. I'm waiting for that to go through, and as you can see, it went through. It's okay. I'm going to again save to database. I just press space to repeat the command. Save walls, wall panel 1, WP1, sorry, and let's save that. Good, that's all saved, and let's go to slabs now, and let's select all slabs S1, and we have 2 slabs here in the model, right? So that's good. Now let's go back to the project manager. That's our impact project, and let's update that. Boom. Here is our 3D model, and as you can see, we also have the panel thickenings here. Let me rotate that. Available, visible, the end cap here visible, end cap visible on this slab as well, and a straight end cap here that we extended by 80 mil onto that slab, and we can also see the extensions of slabs and whatnot, of course the openings as well. Right. So that's our model. Now let's go back to AutoCAD, And in the AutoCAD, I will now create a couple of drawings. Let's say I will create, yeah, let's not go overboard with the drawing so it doesn't take too much time. Let's create drawings for, say, this wall, maybe. Let's create one for the one that has a panel thickening, so maybe this one. And it should also apply the end caps as well for us. Other end cap reinforcement. Yeah, so maybe those two walls, because this will go fast for us to have a look at and edit and play around with. Yep. Oh boy. Okay, so those drawings are now done. Let me create drawings. You can't really create drawings at the same time for sandwich panels and solid panels. You have to do that separately. So let's go create maybe here, maybe this one. Yeah, okay, those two are simple enough and should be also quick. Oh, I forgot to create a connection here. I hope you forgive me. Yep, that's quite all right. Okay. So while that's thinking, we'll also, after that, we'll also quickly do the drawings for the slabs. So we'll see, or maybe we'll go to the reinforcement template for slabs and see what's set up there. So maybe we can change that and still, you know, update, change the drawing slightly. So all's good. All right, so let's go to reinforcement templates and let's go for slabs. Import those, import, okay. Let's see what's in there. Okay, so that's basically double mesh, double rebar. Yeah, that's gonna be double mesh reinforcement for the slabs. Yeah, if we had end cap reinforcement, we could do that, but I didn't create that for this particular type of slab. Let's quickly create drawings from the slab section. You have to click the slab section. One thing we can very quickly do, we can create opening in a slab. Let's select. Say it's going to be this slab. Let's create a cutout and let's do that. Rectangular opening, say like this dimension, and yeah, I can update lifts, and I need to also update the slab. And slab. Use existing element mark. I will use the existing mark, so it will still use that S1. It should automatically apply some opening reinforcement for us. And that's it. So let me create a drawing for a slab. Let's go for this one, accept that. The other one will skip. So, you know, it's a slab, pretty simple reinforcement, but you get the idea of how quickly that is done for various elements. Yep, the drawings are done. So let's open the wall drawings for whichever walls we have. I'm just going to select the ones that we have. It will automatically open all the drawings that were created. So this is, I think, 4 drawings for our walls. So we've got 2 wall panels, two solid wall panels, 2 sandwich wall panels. Yeah, we see something there. Yeah, that's that. And let's open that slab as well. Slab. There's so many icons, sometimes I have a hard time finding the proper one. All right, okay. So that's the very quick automatic drawing of a slab. We can also create a 3D preview of that. There's a section view as well for the slab, both the longitudinal and transverse. Of course, we could work with adding some reinforcement to openings. Need be, there's tools for that. So no problem there. Maybe we can try doing that. Sorry, this comment is for walls only. Draw template proposal edge. Okay, so maybe we'll forgo that for now. We have some other stuff to show for sandwich panels. So to quickly demonstrate drawings that we get. All right, so here we have a bunch of stuff. So immediately on the drawing, there's some reinforcement that's shown. There's custom materials that were placed in that wall automatically while we were creating connections, and as well we also have that edge reinforcement that's been created, right? We can convert that to a reinforcement group, or we can leave it as is, as 16 B10 bars at 20. So we specified that distance 20 centimeters, 200 mil. We can convert that to a reinforcement group. So I'll quickly show that. Convert reinforcements to a group like that. Let's leave it like this. This will basically create a group for you, and you will skip some dimensioning here. And if I go to element and refresh the reinforcement, this will refresh the reinforcement in a drawing, which will show the reinforcement group that has been created, and it should also update the schedule for that, right? So that's our group. So that's the bars that we created, 480, as you remember. That's the bars that we've specified to be in the end cap, and those are also visible here. So this is also automatically created while rather applied when creating that end cap. And of course, the same case for the sandwich panel that doesn't have any openings but has a panel thickening, and that panel thickening is here. If we go to that view here, here's a different end cap. It's a straight end, and here we have the WD3481 end cap and the reinforcement of the end cap as well. We also have that panel thickening. Of course, we can edit that panel thickening here. We can move this line here slightly, and we will then edit the geometry of that panel thickening. So we can do that. I can go ahead and make that shorter, but I need to regenerate the geometry of the drawing as well. So I'll do that. And after that, I'll show you how we can add reinforcement to that now on the drawing, right? So it can be applied, and yeah. All right, so the drawing was recreated, and you can see the thickening has been changed, right? Just a matter of now, the thickening is not automatically so basically the dimensions don't automatically detect that there's a thickening there. So the dimensions you have to move away by hand, but that's as long as most of the work is done for you, it's all good, So let us do that reinforcement. So what I want to do is I want to draw a reinforcement group. Okay, so I want to draw a reinforcement group. I have none available here. I would have to create a new one, but thankfully I can import some that are already existing, and I can play around with those and edit those. I don't even need this one really. No, let's cancel that. Let me just import this one and accept that. I just need this one, and that's okay. And I can specify this. So you can immediately see the preview of that reinforcement group and how it will be placed in the panel, right? I can change things around slightly to make it fit into that panel thickening. I know that panel thickening is 150 mil high, and it's 100 millimeters of a cantilever over the wall, right? So let me accept that, and let's verify those dimensions in a section, right? So that's gonna be dimension, that should be 100 mil, which it is, and the height of that is 150 mil, which it should have been, right? So we can go ahead and actually do that reinforcement. Let's draw that group. I'm going to change that. I'm going to configure whatever I have here and change that slightly. So I want to change that shape. I want this to be, so since we have about 200 millimeters of a panel, I'm going to add here 170. Okay, that's that. And for height, since this is 100, 150 of height. So let's make it 110 maybe. Yeah. And let's add more reinforcement here and here. Okay. Also, let's add hooks to that. So it functions more or less better. There's quality of bar, the dimension of bar. We can maybe make that a bar size 8. So it's slightly bigger. And I'm going to then change the placement of that to say bottom right. Okay. And the rotation, I don't want any, like that. So you can see this is a preview. The preview, of course, does not include the panel thickening, so don't worry about that. That's because you can place it anywhere on the height of the wall, which will be then automatically reflected on the section, right? So let me do that. Let me now change that offset slightly, so maybe to 20. Yeah, that's too little of a difference. To 35. That was 225, so let's create more of a cover here. If we create more of a cover, that's going to be like, say, 20, 25. Let's go 250. That should be sufficient, and let's accept that. So now I have my group properly horizontally spaced in an element. It's just a matter of now placing it properly vertically. So I'll start it from this place to maybe this place, and 0 anchorage, because I could specify the anchorage so straight bars would extend past the start and end point, and I will not round that off. And as you can see, I now have that group placed, but it's slightly off. I still need to move that. So let's move that vertically. So it's not exactly on the line. Let's move that by 25. Let's go displacement. Let's go 25. Okay. That's gonna be delta Z 24. Okay, should be sufficient for the demonstration. It should be perfect. And let's refresh the drawing now. What's going to happen is this is going to be a group of reinforcement. It's also going to be detailed on the side, so you will have that group nicely detailed. But while refreshing that drawing, I will also refresh the section where the section will be visible for you, or where the reinforcement will be visible. So as you can see, we do have that group added here, right? And we also have the group visible here for us. All right, so that's the group. Group is called A2 because it's a second group in the drawing set. And as you can see, there's also the unconverted edge reinforcement, which I can of course now change to group as well. So let's convert reinforcement to a group, right? Let's go leave that like that. And I can again refresh drawing and the material takeoff. Here's the material takeoff. I'll zoom in once the drawing updates for us with that group visible, and I'll go ahead and also create a 3D view of the reinforcement for you, so you will be able to see the reinforcement more clearly in 3 dimensions in AutoCAD, or to place it on a view. Okay, so here's the schedule for the bars that are bent, and where's the reinforcement here. So here are the groups, the A1 and A3 groups available, the number of those groups in the element, total lengths, and the groups dimensioned, right? So you have the dimensions of bars, you know how to bend them, all's good. Right? Again, section view, you have this visible for you as well for the end cap reinforcement. Now in here, there's, as was the case for the columns, there is a 3D model of the element. I can just click on that icon here. This is a changing for a solid reinforcement view, and for the preview, I want to include the reinforcement. I want the cast-in material as well. And like that, I have a 3D view of reinforcement. So that's the that's the panel thickening reinforcements. You can verify that it's there. There's also the no, that's not this one. That's the inner panel additional end cap reinforcement for you as well. So if you go to the reinforcement view drawing, you've got all the reinforcement, you've got the groups, you've got the schedule, you've got the 3D view as well, and 2D views for inner and outer panel. And in the main drawing, you also have the 3D view, of course, maybe some adjustment to the viewport, but you've got the end caps that are created with this. You've got the formwork view, formwork drawings as well available. And for the standard panels, well, you can see in the drawings the wire loops, casting materials, weld plates that have been placed. Wall panel 6. Wall panel 6. Did we? Where's the end cap reinforcement? Yeah, that's basically the automatic drawing creation for you. You also have that preview, can add the reinforcement in that. Yeah, I think that would be it for today. Actually, we've covered a lot of topics in quite a bit of detail as well. So yeah, with that, I would like to thank you for your attention. Let's go back to the model. We've done a lot in terms of modeling, in terms of connecting elements. So we've created joints, we've used casting material templates, we've talked about reinforcement templates and reinforcement in the end caps, how to add stuff to end caps. We've generated shop drawings for our elements, right? So there is a ton of stuff that we've covered in this video. I'd like to thank you all for your attention for this slightly bit over an hour. With that, I would also like to invite you to our next webinar, and you can find out about it on our strusoft.com/webinars website, or you can just go to our main website, go to resources and upcoming webinars. And the next part, the part 3 of this series, will be Precast Detailing and Impact, part 3. I will focus on form slabs, double walls, and linked elements, so your staircases or other types of non-standard elements. And for if we have any Polish viewers here, then be sure to check out the part 2 of a Polish version of this webinar. I'll be doing that as well in a couple of weeks on November 8th. So not far off. I very much would like to invite you all to that. And also, as well, I would also like to invite you to our LinkedIn site, our Strusoft, either Strusoft official or Strusoft Polska YouTube channel, and to our official website, as well as the wiki for Impact, which contains basically everything that I've shown you and way more stuff than I'd be able to cover in any single webinar. So again, thank you for your attention and see you in the next webinar.